So let's look at significant figures. There are 5 different rules. We'll look at all these rules, don't worry, in more details with some examples, okay? So, rule number 1, all non-zero digits are significant. Okay, some examples here is, let's say I have 47. Both numbers are significant, so I will say there are, in this case, there are 2 significant figures. Why 2? Because there are 2 numbers. So if you are thinking why is there 2, it's just because they have 2 numbers. Okay. Give me another number would be, let's say 30,000. Sorry, should I use 30,000? Okay, so let's say 34, 78, 9. Yeah, 789. Okay, 34,789. This is also significant, and I can say that there are 5 significant figures. Okay, this is rule number 1 when it comes to a number. Okay, rule 2 is that all zeros between non-zero digits are significant. Okay, actually this is quite simple. So for example, I have 1004. Okay, we consider zeros as significant as well. So I would say that there are 4 significant figures. Okay, and next, let's give an example. We're talking about whole numbers here, integers here, so we haven't reached decimals yet. So even if I have like 4,001,003, like 4,001,003, there are actually 6 significant. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, there are 7. Sorry, 8. There are 7 significant figures. Okay, all the zeros in between 2 non-zero digits, or even more than that, are considered significant. So there are 7 significant figures. Okay, how do we count them? We always count them from the left to right. So this is the first significant figure, second. Okay, this will be the third. Okay, this will be the fourth. This will be the fifth. This will be the sixth. And this will be the seventh. Okay, this is how you count significant figures. Okay, it's not that difficult. So it's just a matter of counting, and so on and so forth. So now we have 2 rules. All non-zero digits are significant. All zeros between non-zero digits are significant. Okay, let's go to the decimal. Okay, decimals. Okay, all zeros after a non-zero digit are significant. Example, in a decimal, right? So let's see. Okay, before I go on to some examples, we all know you can convert cm to meters, right? So 1 meter corresponds to, is equal to 100 cm. So if I have, let's say, 5.7 cm here, so this is 0.057 meters. Okay, this is also one way to express lengths in meters, right? So in this case, which is more accurate? Okay, for 5.7, we say that it must be 5.7. So I would say that there are 2 significant figures here. Okay, a short form of writing significant figures is SF. So 1, 2. Then what about this? Do I say that these and these are significant? Okay, not exactly, right? Since these 2 are equal, so 5.7 is equal to 0.057. In this case, there are 2 significant figures. Hence, that's why only these and these are significant. Hence, I will consider this as the first significant figure and the second significant figure. Alright, so let's show you some examples. So let's say I have 4.325. Okay, in this case, there are, this is the first, second, third, and fifth. First, second, third, and fourth. Okay, so there are 4 significant figures. can also have 0.432. Let me look at okay, so maybe I should not put that. Let's not do this example. So let's say I have 69.34, so 348687. Okay, in this case there are 6 significant figures. Okay, so that's rule number 3. So rule number 1 is that all non-zero digits are significant, so that's pertaining to whole numbers or integers. Okay, maybe not whole numbers, let's say integers. Okay, pertaining to integers. Okay, and all zeros between non-zero digits are significant. This is also pertaining to integers. Okay, next we have the all zeros after a non-zero digit are significant. Oh, I forgot to bring up one example. So let's do it somewhere here. Okay, so let's say for this case, okay, one of the examples I have is maybe 8.4300. Okay, so based on this rule, all zeros after a non-zero digit in a decimal are significant. Okay, in this case, I consider the zeros here as significant as well. Hence, there are, in this case, 5 significant figures. Okay, something to take note here, it's quite important. Okay, all zeros after a non-zero digit in a decimal are significant. Okay, now let's look at this. In this case, in a decimal, all zeros before a non-zero digit are not significant. Let's use. I don't think this example is quite I don't think this example is quite right. But let's just look at the rule. Okay, so I think you can just cancel out this. Okay, so in this case, in a decimal, all zeros before a non-zero digit are not significant. Okay, some examples would be 0.046. Okay, in this case, these two are not you will count the first significant figure from the non-zero digit. Okay, so in this case, there are 2 significant figures. Okay, next we have, let's use another example. 0.04 no, maybe not 0.04, 0.00012. Yeah, 1, 2, 3. Okay, in this case, with all the zeros in front, where there's no non-zero inside, there's no like non-zero digits in front, we'll have only 3 significant figures here. So there are 3 significant figures. Okay, so quite simple. Rule number 4. Rule number 5. In whole numbers, the zeros at the end may or may not be significant, and it depends on how the numbers are approximated. So in this case, for example, we have this number 7,500. So 7,500, you can say there are 2 significant figures, you can say there's 3 significant figures, and this depends. Okay, so it really depends on the case. So for example, I have 41300. Okay, I can say this can have 3 SF, 4 SF, or 5 SF. All is fine. It depends on how it's rounded up. Okay, we cannot say that this has 2 SF because this is not true, because it has at least three non-zero digits. So minimum you need to have 3.